Okay, so exact numbers, they are not measured. They are things that are either counted, so we've just talked about counting, or there's another instance in which a number can be exact, and that is when we define them. Okay, so it's either counted or it's defined, and those are said to have an infinite number of sig figs. The symbol, do you guys know the symbol for infinite or infinity? The little sideways 8 almost, like that. Okay, so I will sometimes use that. So here's some counting examples. You can have 4 eggs, 8 molecules, 17 elephants, 35 atoms. Those are all exact because they have been counted. Even if you have an elephant who has undergone a tragic accident and is missing a leg, it is still an entire elephant. You wouldn't say I have 1.8 elephants, okay? That's just not the case. When the number gets big enough, you can assume that we have made an approximation and that we did not actually count that many. So if we had a number like 4.3 times 10 to the 6 atoms, if we convert that from scientific notation, if we move our decimal then, 4.3, if we move it 1, 2, 3, 4, 5, 6 places, yes, we end up with 4,300,000 atoms. Is it likely that we have exactly 4,300,000 atoms? Is it likely that someone sat there and went 1 atom, 2 atoms, 146, 1,372, 1,370? Like, no, okay? Nobody sat there and counted that many atoms. So that will be an approximation. Okay? And if it is an approximation, then it is not exact. And if it is not exact, then it does not have infinite sig figs. How many sig figs are in that number? 2. Okay, 2 sig figs there. Two sig figs. Here are some examples where things have been defined, and they are defined exactly. The Council of, I don't know, probably the System International, anyway, some body of international scientists has come up and said 1 inch is exactly 2.54 centimeters. It's not 2.541, it's not 2.5406, it is exactly 2.54. So this has infinite sig figs, and this 1 inch also defined has infinite sig figs. So if you're dealing with those numbers where we've defined it, those are also infinite. In 1 minute, do we have approximately 60 seconds or do we have exactly 60 seconds? Exactly. So 60 seconds is infinite and the 1 minute is infinite. Approximately 24 hours in a day or exactly 24 hours in a day? Exactly, okay? 100 cents is exactly equal to $1. 4 quarts is defined as a gallon. 1,000 milliliters is defined as a liter. 3 feet is defined as a yard. 100 centimeters is defined as 1 meter. All of those have infinite sig figs, okay? Now, there are things where 2 things are equal to each other, but they are not exact. So 1 mile, you will often see 1 mile is equal to 1.6093 kilometers. That's actually a rounded off value. Okay, it's actually 1.6093 blah-de-blah-de blah. Yes, and I don't know what digits come afterwards. So unless it says exactly, which this one does not, then you can assume that that number with the decimal is not exact. So do you see how up here it says 2.54 centimeters exactly, that means that has infinite sig figs. But if you see something with a decimal, where did it go? And it does not say exactly, then this one would have how many sig figs? 5 sig figs. Now what about the 1 mile? You think that's like 1 sig fig, or is that infinite sig figs? It's going to be infinite because you're saying 1 mile, exactly 1 mile, and then it's like approximately this many kilometers. It's a pretty good approximation, but it's still an approximation. Okay, so that's an infinite number. 1 pound. How many sig figs in 1 pound? Infinite. And how many in 453.595? 1 kilogram. How many in the 1? Infinite. Are you noticing something? Every time we define a single unit, 1 mole, 1 atmosphere, 1 meter, all of those ones are just infinite sig figs because we're saying exactly 1 meter, exactly 1 ounce, exactly 1 quart, whatever. But the other numbers, unless it says exactly, then you can assume that this one would have 5 sig figs. How many in 6.202 times 10 to the 23 particles? 3 sig figs. 101.325 kilopascals. 6 sig figs. Okay, and we could go on and on just to remind ourselves how many sig figs in this number here. Tell your partner. Is it 5 or 6? 5. Why? Leading zeros are never significant. Those are those zeros before your number starts. Okay? So that's how those work. One thing you'll notice about a lot of these ones where they are not, you know, the number with the decimal is not exact, they are converting in between one style of measurement and another style of measurement. All of the ones I'm highlighting right now, these are all imperial measures. These are what you use if you're in the United States. Yes, a mile, a pound, an atmosphere, a yard, an ounce, a quart, a gallon. Okay, all of those are imperial measures, whereas metric, kilometers, grams, kilograms, meters, grams, liters, those are all metric. So in general, when you are converting between different unit systems, the numbers won't be exact. Just the one will be exact. The one that says 1 will be exact, but the other one will be not exact, unless you see the words exactly. Okay, yes. 2 or 3? Oh, you mean like down here? Oh, they will, if you're counting them, then they're infinite. But normally when we're defining a unit, like I'm not going to tell you that 2 centimeters is equal to 4 point or, you know, 5 point whatever. Like it's always going to be one of these is equal to something of the other. Okay? So if you are converting within the American, British, imperial system, those are going to be exact numbers. So there are exactly 12 inches in 1 foot. There's exactly 3 feet in 1 yard. So as long as you're converting within the same system, everything is going to be the exact. Same thing with the metric system. All of those, you know, 100 centimeters equals a meter, 0.1 centimeters equals 1 millimeter. Those are all exact. So everything up here, this is imperial, This is imperial. That has infinite sig figs, and that has infinite sig figs. This is metric. This is metric. That means that these both, because they're in the same unit system, they are infinite sig figs. So it's really only when you start going between the two different unit systems. And if you're like, how do I know if I'm going between the two unit systems? That implies that I know all my imperial units. I think, do we have? No, we don't, but that's okay. It will be in the next unit when it becomes important. We will have a bunch of lists of imperial measures for you in the next unit. Conversions between imperial and metric are not exact. So this is metric. This is imperial. And so the 1 is exact, but the 454 has 3 sig figs. Per means exactly 1. So 45 minutes per hour means 45 minutes per exactly 1 hour. Or sorry, not minutes, miles. There's not 45 minutes in an hour. Okay, 45 miles per hour. Is a car going exactly 45 miles per hour? No, that is an approximation, but is that per hour exact? Is that 1 hour exact? Yes. Okay, percent means per exactly 100. But, you know, if I say 25.9%, is that an exact number? No. Constants are often not exact. They are derived from measured values. So here's some constants. Avogadro's number. You remember that 6.02 times 10 to the 23 that we said you don't need to know yet? You still don't need to know it, but you should know that it is not exact. Once again, if you see decimals in a number and it's a per 1 something, unless it says exactly, you can assume it's not exact. Okay? And in fact, if you were taking AP chemistry, you wouldn't use 6.02 times 10 to the 23, you would use 6.022 times 10 to the 23 because that's what they give you in the AP data booklet. And if you were actually wanting to know the actual defined value of a mole and you wanted to use all its digits, let's find out what that is. If this will wake up. Okay, here we go. Mole unit Wikipedia. What does it say? It'll give me all the digits. Oh, here we go. Oh, here it is. 6.022140076 times 10 to the 23. That's the exact number. That's what a mole is defined as, is that many particles. Do you want to write out that whole number the whole time? No, so you will just write out 6.02, and that 6.02, because it has been rounded and estimated, that's going to only be 3 sig figs. Okay? If you were to use all of that, it would be exact because now it is defined, but if you round it off, it's not. Okay? Alrighty. Oh, look, and I had that number right there anyway. I did not need to go look for it. Okay. So there are some exercises here. If it involves a measurement, it is inexact, not exact. If you can count it, it is exact. If everything is metric, they're both exact. If everything is imperial, they are both exact. If one is metric and one is imperial, then the one that says 1 will be exact, and then the other one will be inexact. So go ahead and try those. Okay? Also, like a second place or something like that, but I don't know the exact term. Oh, that's very cool. Oh, it's a small room. Very cool. Yeah, I can imagine. Yeah. Super. Cool. When you are done, I know you started working on equipment B last week sometime. You can carry on with working on equipment B. I brought out the balances again. I'll go and grab some electronic balances as well because you will also need those. And if you finish that, you can work on equipment C. Okay. Yay. we'll share. We have 1, 2, 3, 4 on this card, and then there's a fifth one right here on this table. Okay, I'm going to wheel these over to the other side. Yeah. So once you are done that, you can work on equipment B. If you've not finished equipment A, of course, you could work on equipment A. So you'll be working on equipment B. A, B, and C. And I was going to mark quizzes for people so they can have them back today. Yes. No, you can't because you don't actually have a number, so no, don't worry about it. Okay. That would have 2 sig figs, yes.
So I don't need to divide them.
No. Yeah. Yeah. Or actually, there would be 1 because that's your measurement there. And then this 12 stitches would be exact. So there's actually 2 numbers in there. Ah, tricky, huh? Okay, so I got that, and that. And if you think your balance is broken, call me over and I might be able to help you out because it probably isn't. Hi. You think your balance is broken? Probably not. No. Because before you use the balance, here are the steps to making sure you're out of balance. Where should it be? Is this the bottom one? Or is that the top one? Ah. Yes. Yes. Beautiful. Are you looking for balances? They're on the bottom shelf of this balance. Yeah, yeah. They're just hiding. They're camouflage. Beautiful. Because there's air moving. Okay. Yeah, that's fine. There you go. Well, you can keep it for a while. Yeah. Don't put your balance away once you've zeroed it. You're going to do some stuff with it afterwards. Okay? Hello. All right. Very good. We would like to send you through perfect. It's okay, I'll sort it. It's all good. There we go. Hello. Are you zero? Okay. Oh, this is your beaker. Excellent. Good. And have you recorded the mass? Georgia. Hi. Okay. Yes. Alrighty. Do you have the right number of digits in that measurement? You think so? Okay. So what is your smallest division here? Point something, point what? Okay, more position than that. And so that's going to be 0.35, yeah, or 0.349 or something like that. Yeah. Beautiful. Okay. Hi.
Oh, yeah. Is this correct?
That looks good. Yes. There you are.
Thank you.
Excellent. Okay, and then you can answer. Right.
Part B, never touched part C.
So if it's too far up, you have to move it this way towards it. If it's too far low, sit away from it. Yeah. So now you're at zero. Maybe I was a little heavier than you. Well, no, you're maybe you're this, so I will try this for you. We did a factor work on two wives on ours. That's like the last no. Yes. Yes. Sign here and here and here. Okay, you're really close. You're missing one thing from that measurement. Yes, there you go. Here's my autograph. Famous me. We're absolutely happy someday. There you go. Yes. Oh no. Yay. Hello. All right. That looks good. Thank you. Very good. Is that the math in millimeters? Yes. Yeah. Okay, so because this one is downwards, it's correct. Yeah. Yes. You would just have to go through this and say, I was measuring all measuring mass, and then whatever units they were in. Actually, a graduated cylinder is a state repair condition, not they're very wide. Zeros. Okay, good. So it looks like it's one all right on those. I will bring that to you. I'll be right there. I know I have to go to quiz for some. I'm coming, I swear. It's all good, don't worry, don't worry. What quiz am I getting? Counting sig figs. Counting sig figs. There we go. Yes. Homer! Get caught up on anything, study for a requiz, come in for flex if you need help or if you need a requiz. So it's catch-up day, okay? Thank you very much. Let's mark that for you right now. 422, 45. I think you just miscounted. Do you want to count that again?
1, 2, 3, 4, 5, 6. It's the 0 I highlighted an 8.
So there's a decimal in the number. So is that 0 significant?
Oh, yeah, it is.
Yeah. Okay, so that one no, but that one yes. That one no. That one no. And that one no. So I think that's because you haven't really done scientific notation yet. So what I would like you to do in terms of scientific notation, there is a video. Let me see if it's in here, 108. Did I put the video in here? No, I did not. Okay. There is this gentleman called Tyler DeWitt.
Yeah, I saw his video on the...
On scientific notation, or the other one?
The other one.
Okay.
What's it called?
I can't remember, but if you look him up and you look up scientific notation, he's got a great little lesson on scientific notation, and then we can talk about these ones, and then you can redo this once you know what scientific notation is.
Okay.
Sound good? Yeah. Okay, awesome. Hello. Absolutely, yeah. Hi. Measurements quiz. So it would be anything from this section here, 1.4. So it's like literally just like, well, not this because we already did that, but anything, it's going to look like literally where you're given one of these and you have to make the measurement. Yeah. There you go. Hi.
Can I get my code?
I can tell you're thrilled, Jeremy.
Talk about it. At least 4175. Like, at least 4175. Give him a 4.75.
Come on, at one point in his life, Jeremy has to have fun, right? Like it has to happen for once. Maybe this is your one time. Are you hyperventilating on me?
Better on the quiz than on the quiz.
Yeah, one life.
Oh, I want nap time. It's not nap time, but I want nap time.
I want you to all the way back.
If you retest, you get the better mark or the second mark?
You do. You get better.
Okay. So you come in during flex, right?
Yes?
Okay.
Hi.
Pardon me?
Are we doing more work on mole volumes today, or are we moving on to a different
We're moving on to a different one.
Okay.
So unless you have questions about the molar volume, yeah.
And then, so, can I take my test tomorrow?
Yeah.
Okay.
Yeah.
Sorry, I just had tests.
This is my other class, don't worry about it.
Oh
Yeah.
no, so tonight's homework, is it getting caught up and everything?
No, this is block 3. I know, right?
Okay, sorry, Miss Spence, do you have somewhere I can plug in my phone?
Yes, in fact, every desk, every one of these has those on the front. So you can actually just plug in and then put it on the, yeah. Oh my God, okay. Okay, 5.5A. 5.5A, you find stage. Okay, so Monsieur Gay-Lussac is one of these extraordinary figures in l'histoire des sciences who could truly be called an adventurer. He was interested in lighter than air balloons, and in 1804 he made an ascent to 23,000 feet. And exploit that set, honestly, I only took grade 11 French and that was like 30 some odd years ago, so you know. An exploit that set the altitude for several decades. To better control these lighter than air balloons, Monsieur Gay-Lussac carried out several experiments on the properties of gases. And in 1808, he discovered the law of combining volumes. And for anyone who wants to know what page we are on page 87. So what he discovered was that at a given temperature and pressure, oh, hang on. I'm going to press